Hi viewers, welcome to Aviation and Air Traffic Control Keep Educating Yourself series. This lecture is about air traffic services theory. So air traffic services is a generic term which means variously flight information service, alerting service, air traffic advisory service, air traffic control service. Air traffic control service includes area control service, approach control service, or aerodrome control service. So objectives of air traffic control services are 5. First is prevent collision between aircraft. Second, prevent collision between aircraft on the maneuvering area and obstructions on that area. Third, expedite and maintain an orderly flow of air traffic. Fourth, provide advice and information useful for safe and efficient conduct of flights. Notify appropriate organization, this is the fifth one, regarding aircraft in need of search and rescue aid and assist such organization as required. So these are 5 objectives of air traffic services. So divisions of air traffic services, this is divided into 3. First is the air traffic control service. Air traffic control services are further divided into 3: area control service, approach control service, and aerodrome control service. Then the second division of air traffic services is the flight information service, and the third one is the alerting service. So air traffic control service, what they will do, they will prevent collision between the aircraft. This is their objective. Prevent collision between aircraft on the maneuvering area and obstruction on that area. Expedite and maintain an orderly flow of air traffic. Flight information services will include provide advice and information useful for the safe and efficient conduct of flights. Alerting service, notify appropriate organization regarding aircraft in need of search and rescue aid and assist such organizations as required. Information regions, those portions of the airspace where flight information service and alerting service will be provided shall be designated as FIRs. Control areas and control zones, those portions of the airspace where air traffic control service will be provided to IFR flights shall be designated as control areas or control zones. So here we have spoken about IFR flights. Now we will discuss about the VFR flights. Those portions of control airspace wherein it is determined that air traffic control service will also be provided to VFR flights shall be designated as class B, C, and D only. Controlled aerodromes, those aerodromes where air traffic control services will be provided to air and traffic shall be designated as controlled aerodromes. Now, this is the classification of airspace. Classification of airspace as per ICAO have been done in 7 classes A to G. It further classified based upon traffic permitted, separation provided, services like air traffic control service, which we have just discussed, traffic information or alerting advisory service. Then speed limitation, radio communication requirement, and whether these flights are subject to ATC clearance in a particular airspace or not. For this, you can refer our separate video on this one. Now, performance-based navigation operation. So every state has to prescribe what performance-based navigation they are utilizing in their airspace. So what is PBN? PBN is an area navigation based on performance requirement for aircraft operating along ATS route, instrument approach, or in a designated airspace. So performance requirements are usually expressed in navigation specifications. These are of 2 types, RNAV specifications and RNP specifications. When we are describing any performance, it should be in terms of accuracy, integrity, continuity, availability, and functionality. So for a particular airspace concept, it has to be in this way. Then performance-based communication operations. This has to be specified by state again. What is performance-based communication? This is communication based on the performance specifications applied to the provision of air traffic services. And required communication procedure specifications includes communication performance requirements that are allocated to system components in terms of the communication to be provided and associated transition time, continuity, availability, integrity, safety, and functionality, which are needed for the proposed operation in the context of a particular airspace concept. Then performance-based surveillance operations. In applying performance-based surveillance, RSP specification shall be prescribed by states. So what is performance-based surveillance? These are surveillance based on the performance specifications applied to the provisions of air traffic services. And required system performance specification, surveillance performance specification includes surveillance performance requirements that are allocated to system components in terms of surveillance. Here, instead of communication, surveillance word will come. To be provided and associated data delivery time. In that one, it was communication. Here it is data delivery time. Thereafter, continuity, availability, integrity, accuracy of surveillance data, safety and functionality needed for the proposed operation in the context of a particular airspace concept. Designation of the units providing air traffic control air traffic services. First is flight information center. Second is area control center. Third is approach control center. Fourth is aerodrome control tower. So aerodrome control is further divided into three parts: aerodrome control tower, ground control, and clearance delivery. Specification for flight information regions. So FIR is an airspace of defined dimension within which flight information service and alerting services are provided. Flight information regions shall be delineated to cover the whole of the air route structure to be served by such regions within its lateral and vertical limits. Where FIR is limited by an upper FIR, the lower limit specified for the upper FIR shall constitute the upper vertical limit of the FIR. It means that both levels should be that lower limit of the lower FIR, upper limit of the lower FIR, and the lower limit of the upper FIR should coincide. And those should coincide, shall coincide with a VFR cruising level. So suppose lower FIR is at a 245, up to 245, it's a lower FIR. So upper FIR will start from 245 and above. So here, up to 245, one unit is responsible, and above that one is the upper FIR is responsible. And we will be allocating levels there will be no 500 feet levels will be allocated to anyone. We will be allocating like 200, 210, 220, 230, 240. So up to 240, it will be the responsibility of lower FIR. And 250, 260, 270, that will automatically come into the jurisdiction of upper FIR. So in these cases, the lower limit of the upper FIR and the upper vertical limit of the lower FIR shall coincide. And that should coincide with a VFR cruising level. So this is a pictorial view of all the FIRs. Specification for control area. So if we are talking about control area, first of all, we have to understand that what exactly it is. So it is a controlled airspace, and from where it is starting, it is extending upward from a specified limit above the earth. So it means it is not starting from ground. It is somewhere above the earth. It is desired to protect the IFR flights. So control areas are basically to protect the IFR flights which are subject to the provision of air traffic control services. So one thing we have understood from the definition that it will not start from the ground. From ground, what will start? That is control zone that we will discuss in next. So here, what should be the lower limit of control area? So if we have to establish a control area, there will be a lower limit and an upper limit. So a lower limit of a control area shall be established at a height above the ground or water of not less than 700 feet. So it should be at least 700 feet or above. It should not be less than this. And when the lower limit of a control area is about 3000 feet mean sea level, it should coincide with a VFR cruising level. So suppose if it is about 3000 feet, so you have to give the lower limit like it's starting from 3500 feet, 5500 feet, 6500 feet, 75, 85, 95. So these level will be the lower limit of control areas. The lower limit of a control area should, when practicable and desirable, is why we are creating this one, so that VFR flight should have a freedom to operate below this control area. Now, control zone. We have already understood control area. Control area is starting from a certain bow height, which should not be less than 700 feet. So control zone, it's a controlled airspace extending upwards from the surface of the earth to a specified upper limit. The lateral limits of control zone shall encompass at least those portions of the airspace which are not within control areas. So if we are talking about control zone, it will not cover those airspace which are already into control areas and containing the paths of IFR flights arriving at and departing from aerodrome to be used under IMC. So it will protect the flights which are operating near at an aerodrome, so that, and from where we have to protect it, it is required to protect from VFR flights. So what should be the lateral limits of control zone? Minimum should be 5 nautical miles. It should not be less than this one. And it should be from the center of the aerodrome or aerodromes concerned in the direction from which approaches may be made. So minimum 5 nautical mile lateral limit of control zone is mandatory. Now, if a control zone is located within the lateral limits of a control area, so lower will be control zone, upper will be control area. So it shall extend upwards from the surface of the earth. So if we are talking like it shall extend upward from the surface, so we are talking about control zone. And up to what limit it can go? It can go to the lower limit of the control area. Again, if you will see what we have discussed earlier, as per Appendix 3 to Annex 2, if this limit is 3000 feet mean sea level or above, so in that way we have to use VFR cruising levels for this upper level. So suppose from ground to 5500 feet we have a control zone. So 5500 is about 3000 feet is a VFR. So we will make the VFR levels allocation for the upper limit of control zone. So from the upper level of control zone, that is 5500 feet and above, the control area will start. If it is desired to establish the upper limit of a control zone at a level higher than the lower limit of a control area established above it, or if the control zone is located outside of the lateral limits of a control area, its upper limit should be established at a level which can easily be identified by pilots. So it is saying that there should be no ambiguity. Pilot should be aware of it that here the control zone is starting. So there is one more interesting fact which you will get from the definition of the control zone. If we are talking about the control zones, so the QNH, the below transition level, when it will be going to descend and it will be going to set QNH. So it is applicable in control zones only. And control zones, sometimes they are making it 25 nautical miles, sometimes they are making it 30 nautical miles. So, but the minimum should be 5 nautical miles from the center of the aerodrome or from the direction of the approach. So this is the main purpose. Control zone is to protect, like all your instrument approaches will be a part of control zone, or your holdings over the facility which is going to provide you aid for landing or departure will be contained in this one. SIDS and STAR will also be a part of this one. Now, identification of air traffic service units and airspace. So how you will identify that in which airspace you are and which air traffic service unit is operating in that one. So here it has been given like this. An area control center or flight information center should be identified by the name of nearby town or city or geographic feature. So if you are going towards any particular airport, so like this is Bangalore area, or this is Kolkata flight information region. So like this, they have to specify. So it will be easy for pilot to identify that at which area control center they are, in which airspace they are operating. An aerodrome control tower or approach control unit should be identified by the name of the aerodrome at which it is located, London Tower, Heathrow Tower, like this. A control zone, control area of flight information region should be identified by the name of the unit having jurisdiction over such airspace. So it's just for the identification. Now, how establishment and identification of ATS route have been done? So routes have been divided into 4 groups, and each group is like ABGR. It's a non-RNAV routes and regional network of ATS routes. So you can say like this, it's a non-RNAV. So it's an old routes and it's used for international. LMNP, these are RNAV routes. point-to-point flying is possible, and these are a part of regional network of ATS routes, means international routes. Hotel, Juliet, Victor, Whiskey, these are non-RNAV routes and domestic network of ATS routes. So for any state or country, they will prepare routes of H, J, B, W. They will be used for their domestic leg. Q, T, Y, Z, these are RNAV routes, but these are also used for the domestic legs only. Now, if we have to supplement some letter, so it can be prefixed or suffix. First, we will talk about the prefix, what we can add to the ATS route as a prefix. So basic designator we have already discussed. There are 4 types. Now, in those 4, we can add some letter as a prefix. So K, U, S. K is copter, U is upper, S is supersonic. So as the name says, K is indicate a low-level route established for use by helicopters only. U is the route or portion is established in the upper airspace. S are the route established exclusively for the use by supersonic aircraft during acceleration, deceleration, and while in supersonic flights. Now we have talked about the prefix. Now we will talk about the suffix. So basic designator are 4, out of which any one will be used. Prefix we have already discussed are 3. Then one supplementary letter may be added after the basic designator of the ATS route. It can be F or G, Foxtrot or Golf. If you are putting Foxtrot, it means this is a route where advisory service only will be provided. If you are putting Golf, it means that we will be going to receive only flight information service. So the ATS route designator shall consist of prefix K, U, S, copter, upper, super. Then basic designator letters are A, B, G, R, L, M, N, P, H, J, V, W, Q, T, Y, Z, and followed by one number from 1 to 9er. Suffix can be Foxtrot and Golf. So the number of characters required to compose any ATS route designator shall not exceed 6 characters. So whenever you will be going to see your charts, so you will find out that any ATS route, it will not be exceeding 6 characters. Maximum characters are permitted are 6 characters only. We have I have taken few examples. Upper number 571 route, Golf 473, Juliet 1. So maximum numbers you can use is 9er, these 3. So here 473. You cannot have like route like this, Golf 4739er. So it is exceeding this one. You can have only 3 up to 3 numbers. Next, minimum flight altitudes. Minimum flight altitude shall be determined and promulgated by each contracted state for each ATS route and control area over its territory. So it will be published in AIP and en route section. The minimum flight altitudes determined shall provide a minimum clearance above the controlling obstacle located within the areas concerned. So if you have to go from the obstacle, it should be 1000 feet above. This is the obstacle. So you see this is 1000 feet above. So it will be published in minimum flight altitude. If it is in mountainous region, so the minimum required is 2000 feet. So they will do air survey. Based upon that, they will find out the obstacle, highest obstacle they will take in this area, and above 2000 feet, they will establish minimum flight altitudes. To indicate the state of emergency, aircraft might operate the equipment as follows. They will set transponder code 7576700. And if they are using ADS-B or ADS-C, they will use appropriate emergency signals, and they can transmit the appropriate emergency messages via CPDLC also. In-flight contingencies. An aircraft known or believed to be in the state of emergency, including being subjected to unlawful interference, shall be given maximum consideration by the air traffic service providers, assistance and priority over other aircraft as may be necessitated by the circumstances. So distress, it's a condition of being threatened by serious and or imminent danger and of requiring immediate assistance. Mayday, mayday, mayday is a part of this one. Urgency. It's a condition concerning the safety of an aircraft or other vehicle or of some person on board or within sight, but which does not require immediate assistance. So it may develop into this one. So they will say requesting priority landing for reasons so and so. So to indicate the state of emergency, aircraft might operate the equipment as follows. So they will set transponder code 75 for unlawful, 7500 for unlawful interference, 7600 for radio failure, 7700 for emergency conditions, 7000 for VFR, it's a conspiracy code, 2000 whenever if you have not received any transponder and if you are operating in a controlled airspace, so you will set 2000. When you will be in contact with the ATS unit, you will ask for the squawk code. They will allocate you a new code. Activate the appropriate emergency or urgency capability of ADSB or ADSC as we have discussed earlier, and they can transmit on CPDLC emergency messages. So in-flight contingency strayed or unidentified aircraft. So what is strayed aircraft? Strayed aircraft is which has deviated significantly from his intended track, and or he can report that he has lost. Unidentified aircraft is an aircraft which has been observed or reported to be operating in a given area, but whose identity has not been established. So he has not lost, but the service provider are not aware of his identity. So actions by air traffic service units in these cases: attempt to establish two-way communication with the intercepted aircraft. In the case of interception, we are talking about including the radio emergency frequency, which is 121.5. So they will try to communicate with the intercepted aircraft, and they will try to establish on emergency frequency also. Thereafter, air traffic controller will inform the pilot of the intercepted aircraft that you have been intercepted. Then establish contact with the intercept control unit, maintaining two-way communication with the intercepting aircraft, provided with the available information concerning the aircraft. So aircraft which have been intercepted, the unit which has intercepted that one, so air traffic controller will provide the useful information, whatever he has about that aircraft, so that it will help them to identify that it's not a threat. Relay message between the intercepting aircraft or the intercept control unit and the intercepted aircraft as necessary. So there are some SOPs have been made for this. So those will be followed locally, and this will be done. So ATC will, in close coordination with the intercept control unit, take all necessary steps to ensure that the safety of the intercepted aircraft. So safety is a prime concern. Even in interception, they will give priority to this one, that safety should not be infringed. Inform ATS unit serving adjacent flight information regions if it appears that the aircraft has strayed from such adjacent flight information regions. So sometimes they may deviate. It happens during bad weather. They deviate significantly from their track, or during training, pilot may deviate from his path significantly. So if you are aware, if a one ATS unit is aware, so we'll inform the adjacent flight information region that this has been strayed. Time in air traffic services. So all times are in UTC, which are given in hours, minutes, or if required, then in special case, you can ask in seconds also. ATC unit clocks and other timing recording device shall be checked as necessary to ensure correct time, plus minus of 30 seconds of UTC. Whenever data link communication are utilized by an ATC, clocks and other time recording device shall be checked as necessary to ensure correct time to within 1 second of UTC. Airdrome control tower shall, prior to an aircraft taxiing for takeoff, provide the pilot with the correct time. So this is mandatory for all airdrome control tower. This will be done by a surface movement controller basically. So ATS unit shall in addition provide aircraft with the correct time on request. Time check shall be given to the nearest half minute only.